Hi, everyone. Today we're on Unit 12, Lesson 3, and today we'll be talking about the quotient rule. Let's start with our do now. If f of x equals 2x cubed minus 3x squared plus 2 over x squared, and you're asked to find f prime of x. Right now, we don't have a method to use. Okay, so we'd have to rewrite it. We don't have a rule for this, so we have to rewrite. And when we look at this, we see we have a numerator and a denominator. We call those rational functions. And we know when we're dividing by a monomial, we can split this up and simplify it that way. So we can rewrite this function as f of x equals 2x cubed over x squared is just 2x, right? Negative 3x squared over x squared minus 3, and then positive 2 over x squared is plus 2x to the negative 2. Okay, so there are going to be times when we're going to want to rewrite our function. F prime of x is now 2. The 3 just becomes 0, minus 4x to the negative third, which we can always rewrite with positive powers. Okay. We could actually even go a step further, and we can write this as one rational expression, right? If we were to multiply this by the least common denominator. So it's important for you to understand. I'm going to get rid of that. These are equivalent expressions. Okay, so when we have to find the derivative of a quotient of two functions, we may use something called the quotient rule. Okay, so when we have one function over another function, the derivative is g of x times f prime of x minus f of x times g prime of x over gx squared. When I'm using this rule, like all the rules, I just use the words. Okay, that's my top function. And that's g of x is my bottom function. So I just say the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. To me, it's just a lot easier. Some teachers use a different saying. If you like this, by all means use it. I don't, I mess it up. They use high and low. So you could say q prime of x, or the derivative is low d high minus high d low over low squared. Right, low derivative of high minus high derivative of low over low squared. That one messes me up, but by all means, if it helps you, do whatever you have to do. So just like we did yesterday with the product rule, let's try the do now using the quotient rule and see what happens. Okay. So if f of x equals 2x cubed minus 3x squared plus 2 over x squared. That's my top function and my bottom function. The bottom times the derivative of the top, 6x squared minus 6x. Minus, and remember, this is one piece, minus the top, 2x cubed minus 3x squared plus 2, times the derivative of the bottom, over the bottom squared. We have to clean this up. Okay, so we're just going to always clean up the numerator. And the bottom, because it's a monomial, I'm gonna, square it. But usually I just let you guys leave the bottom alone. So the numerator becomes 6x to the fourth minus 6x cubed. Now here I would have 4x to the fourth minus 6x cubed plus 4x. But remember, I've got that negative out front. Minus 4x to the fourth plus 6x cubed minus 4x all over x to the fourth. Combine like terms in the numerator. 6x to the fourth minus 4x to the fourth, 2x to the fourth. Those cancel out, minus 4x over x to the fourth. I can cancel an x, and I get 2x cubed minus 4 over x cubed. And if you see, we get the same answer. Now, just like the examples we did yesterday, sometimes the quotient rule is not the best option. And sometimes we have to use it. So we sort of have to learn how to differentiate between what to do. Obviously, if you're dividing by a monomial, you're going to want to clean it up first. So let's look at an example where it makes sense to use the quotient rule. If I'm dividing by a binomial, this is a classic example where the quotient rule is what you want to use. My derivative is the bottom function times the derivative of the top. Remember, that's one piece, minus the top function times the derivative of the bottom over the bottom squared. We're going to clean up the numerator, but leave the denominator alone. That's okay. Three x squared minus 3x to the 4 plus 2 to the 6th power. A negative times a negative is a positive. 4x to the 6th power over 1 minus x to the 4th squared. So f prime of x is going to equal 3x squared, negative 3x to the 6th plus 4x to the 6th is just 1x to the 6th over 1 minus x to the 4th squared. And there's your answer all cleaned up. So the hardest part of the quotient rule is after you get that first expression, the cleanup part. Always remember that minus sign in between and make sure you distribute it onto your terms. Let's try another one. F of x equals 2x plus 3 times x squared plus 1. There's nothing I can really do. Can't simplify anything first, so I have to use the quotient rule. The bottom times the derivative of the top minus the top function times the derivative of the bottom over the bottom squared. Clean up that numerator. 2x squared plus 2, 4x squared plus 6x minus 4x squared minus 6x. So it's just a whole lot of algebra. Negative 2x squared minus 6x plus 2 over x squared plus 1 squared. And remember this rule, this expression we just found, it's a rule to find the slopes of the tangent lines. Now I have y equals sine x and cosine x. I told you earlier, any rule we already know, we can now kind of incorporate into these new rules. So I'm just going to treat this like any other function. The bottom times the derivative of the top minus the top function times the derivative of the bottom over the bottom squared. Cosine x times cosine x is simply, right, this is cosine x squared, which we write as cosine squared x. Minus a minus. What is cosine squared plus sine squared? Remember your Pythagorean identity. That's 1. How could we write 1 over cosine squared? We can rewrite it as secant squared. Now let's just stop for a moment. What's another way we can write this function? Isn't sine over cosine the same as the tangent function? So if y equals tan x, y prime equals secant squared x. And this is going to be a rule that we're going to add on kind of next year. Okay. But again, we just got a rule. So if you ever forget your derivative rules, you can always derive them. Let's use this now. So in example 4, g of x equals tan x over x plus 2. Okay, no big deal. G prime is going to be the bottom function times the derivative of the top. We don't have to go through all the nonsense. We know it's secant squared x from the example above, minus the top function times the derivative of the bottom over the bottom function squared. There's not much I can really do here. I'll just rewrite it to get rid of that 1, but you can't, there's not much you can do to clean this up. Okay. We can't cancel an x plus 2 because it would have to be in both terms. Okay. So you just leave it alone. Now let's look at example 5. Okay. Look at what's going on there. Hopefully by now you can recognize that, oh, wait, I can factor both the top and the bottom. Okay. Always look at what you're starting with. Think before you start. Can you simplify this? If you can do it, x minus 3, x plus 2, x plus 2, x minus 2. So I'm really taking the derivative of that. You would just have a lot more to clean up algebraically after. So my derivative becomes the bottom times the derivative of the top minus the top function times the derivative of the bottom over the bottom squared. Up top here, I have x minus 2 minus x plus 3. So my derivative is simply 1 over x minus 2 squared. Now let's use this. Let's use this function. And let's find the slope of the tangent line to f of x. Right? Example 5. At x equals 4, what would we do? Plug 4 into the derivative. Two squared is 4. So the slope of the tangent line to this function at x equals 4 is 1/4. Okay. I want to do sort of an application like this because I don't want you to forget that this rule you get, the derivative, right, is a rule to find slopes of tangent lines. And we haven't done that in a few days. So that's all for today. We've got a bunch of practice problems we can try in class and finish for homework. And we'll see you all tomorrow.